Hey everyone, so this is Coach White, and we are going to go over some reviewing for Unit 10. A lot of you have been asking me questions, so I just decided to make a video for you guys over a couple concepts. I'm going to be screen recording my iPad just so you can see what I'm doing. So let's just go ahead and begin. So a lot of people said they needed help solving functions and going from radical form to exponential. The biggest thing that you need to remember is that we are going to have our x is power over root. So I'm just going to go with this example over here. I'm not going to simplify it or anything. I'm just going to put it in exponential form. So if we put this in exponential form here, I'm going to keep that 4. I'm going to have an x. And then I know that 2 is the base. And I know that that exponent is 1 right here, correct? So it's going to be that power over the root. That's it. This would be your answer right here. Again, I am not going to plug that into the calculator. I just want you to see how we would simplify that, okay? Now, the next thing that we need to do is I'm going to go over this second example right here. You may notice that the radical is going to cancel out with this exponent right here, correct? But if you were to see that, this is how we would write it, okay? So in parentheses, we have 3x squared plus 4b squared. And since this is a square root, the exponent is going to be 1/2, okay? And then we still have that 2 on the outside. Once we notice right here, 1/2 times 2, that is just going to be 1, so that cancels, okay? So that's how that works. We have 3x squared plus 4b squared. And again, I am not going to simplify anything. This is my answer. I cannot combine anything because they are not like terms, okay? Now, the next one that I want to show you is this example over here to the side that says 3 square root of v divided by 7 cube root of v. This one we need to convert into different things. Okay, so I'm going to have my 3. Again, my index is 2 and my power is 1 because this is a square root. So this is going to be v to the 1/2. And then I'm going to convert the bottom. This is going to be 7. And again, I have my index of 3, or my power, or my root is 3 and my index is 3. And then my power is going to be 1. So this is v to the 1/3. Now, I want you to notice with our exponent rules, this is a quotient rule, so we're going to have to subtract these. We cannot subtract them yet. They do not have the same common denominator for our exponents, okay? So I need to come down here and I need to convert this. I do know that the least common multiple for 2 and 3 is going to be 6. So I'm going to change this, okay? I'm going to multiply the top and the bottom by 3. So this is going to be 3/6 now. And for my 1/3, I need to multiply that by 2. So this now becomes 2/6. Okay, please make sure they have the same. So now I'm going to subtract them. 3/6 minus 2/6 is going to be 1/6, and that is left over on the top. So I'm going to have 1/6. That's it, okay? Now, if it asks you to put it in radical form, this is not my answer, okay? If I need to put this in radical form, I need to change it back into a radical. So I'm going to have my 3, okay? And then, oh, I'm so sorry. By the way, we are not going to have a v down here because they canceled. There's no more left. Okay, so I have a 7, and then I'm going to have my v. And remember, looking up here, my root, that is going to be the bottom of the exponent. So this is going to be a 6th, or my bad. This is going to be a 6th root of v. Therefore, this is your final answer. And this right here, this is in radical form. Okay, so if it asks for radical form, that is what you need to put. Okay, let's go into this last example down here. This one may be a little overwhelming. I'm looking at this one right here. But again, we need to convert these into fraction exponents. So again, this is a square root. There is a 2 here. Okay, so this becomes 7h to the 1/2. Again, it's going to be my power over my exponent, or power over my root. Okay, same thing. 3, and I'm going to have h to the 1/2 plus 4. Now, please keep in mind, now this is a 2 right here. And if we look up at the top, we notice right here that it's my power over my root. So I'm going to come over here and I'm going to do an h. My power is 3 and my root is 2. That is how I'm going to convert all of that, okay? Once we get here, we are multiplying these terms, okay? So if we were to distribute, we would distribute like this, correct? Since we are multiplying the terms, we need to add the exponents, okay? So let's start. We're going to do 7 times 3, which is just 21. And then we add our exponents. Okay, so we're going to have h to the 1/2 plus h to the 1/2. 1/2 plus 1/2 is just going to be 1, so this is h to the first. Technically, you don't need that 1. Okay. Next we're going to do is we're going to distribute that 7 times 4, which is going to be 28. Okay. Now we need to add our exponents again. H to the 1/2, h to the 3/2. They have the same denominator, so therefore this is going to be h 4/2, which we know can simplify to just 2. And again, we cannot combine these because they are different terms. That is going to be your final answer, okay? So that's just a little bit of going over radicals, going from radical to exponential form. This I'm going to highlight here, terms that may help you to know, okay? Just seeing, if you see a squared anywhere, it's going to be the square root of x. X cubed is going to be cube root of x. That is how we're going to convert it, okay? That's how we go from exponent form to root form. And my apologies, this should be 1/3. Okay, so this should be 1/3, this should be 1/2, and this should be 1/4. Okay. Those are just some good terms to know. And then knowing how to rewrite it, you're going to have your x to the power, and then it's going to be your root. This is also known as your index. It's going to be x power over root. One way that helps me remember this is roots. Like roots go down, right? These are like little roots on a tree. So the roots is going to be the bottom of the exponent. Okay. Okay. Another thing that people ask me about is inverse and restrictions. I'm going to let you know that on your test, it is going to let you know the restrictions, okay? The biggest thing is when you are looking at restrictions, and this is your graph, and usually it's going to be a quadratic, okay? When we invert this, the inverse of this function is going to look like this, which does not pass the vertical line test. Therefore, it's not a function. So because of that, we need to limit. We need to restrict it just to this side. So if it's saying all my x values need to be greater than or equal to 0, I'm restricting it to just this half of the graph. That's all that's saying, okay? Because then if we find the inverse of this, it's going to look like this. Now it is a function because it passes the vertical line test. That's all that's saying, okay? I'm going to go ahead and erase this so it doesn't confuse us for this next problem. So the first step you're going to do is swap or flip x and y. So as you see right here, here's my original function. All I did is I just took my x and my y and I swapped places. That was the very first step. That's all I did, okay? Once you do that, you need to go ahead and solve for y. So if we're going through the whole process here, I set my step, we add 4 to both sides because remember, we are doing PEMDAS, but we are going backwards, okay? We're going backwards when we solve for this. So we need to add or subtract first. Okay, we add 4 to both sides. Now I need to divide by 2. Please notice I use different colors so you know what step I'm on. Divide by 2. We need to take the square root of both sides. When you take the square root of both sides, you have to take the plus or the minus, okay? Then we subtract 1. So we have -1 plus or minus the square root of x plus 4/2 equals y. When we write this, it's going to look like this. It's going to be f inverse of x. Okay, this right here is not a function. The reason for that is because there's a plus or minus here. To make this a function, you can take the top part of the graph. Okay, so our graph is going to look something like this. This portion right here, okay, that portion is going to be -1 plus the square root of x plus 4 divided by 2, okay? Now, the bottom portion right here, that is going to be -1 minus the square root of x plus 4/2. We know that because if we see this right here, this is a transformation. It is telling me that there is going to be a Roxa, which happened. There was a Roxa right here. There's no Roxa here, so therefore this one's going to stay upward, okay? Again, the only reason you're restricting it is because it needs the inversion needs to be a function, but it will tell you, normally it will tell you what your restrictions are, okay? But please keep that in mind. The only time you need to restrict something, okay? So restrictions are only for even, sorry, that was an ugly E, are only for even exponents, okay? The reason for that is if I do a quadratic, it does not pass the horizontal line test, okay? That is an even exponent. Now, if I have a cubic function, make that a little bit prettier. If I have a cubic function, it passes the horizontal line test. Therefore, I know the new function is already going to be a function. I don't have to limit it. Okay, so that's what the restrictions are. But for inverse, make sure you follow these steps. Flip x and y, and then just solve for y. And make sure that you write it like this as your answer. You need to have an inverse, or my bad, sorry. You need to have your inverse right here, okay? And if it's restricted, it would be this stuff right here, okay? Okay, next part. Write an equation from a graph. The things that you need to know. Your parent radical function is going to be this. F of x equals x, the square root of x. Those are all your table values. You're going to have 0, 0, 1, 1, and 4, 2. If you ever forget that, just plug in 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is going to be 2. And that's where in our table, and again, if you forget, if you're in my classroom, you see that this is on the wall. So we have our 0, 0 right here, our 1, 1, and then 1, 2, 3, 4. And then we have our 4, 2. Bam. This is going to be our parent function right here, okay? Now, when it comes to the domain and the range, what I want to do is for my range, that is going to be all my x values, okay? So I'm going to start this point of the graph on all my x's until I hit, bam, I hit 0. 0 is included, so I'm going to put a bracket. And it goes on to infinity, so I'm going to put infinity. Okay, now I'm going to work with my range, which is all my y values. I'm going to start here, and from the very bottom, it doesn't hit anything. Bam, it hits y equals 0. So I'm going to go over here, and it includes 0. Okay? Now look, my y values are going to go up forever. So therefore, this is also going to infinity. So that would be my domain and my range for my original function. Okay, and that is in interval notation. So this is interval. If it asks for interval notation, please put it in interval for notation, okay? I don't want you to not read it and get a question wrong just because you didn't read the question, okay? Now this graph over here, the biggest thing I want us to do is look at our transformations first. So let's look at them. Okay, there is no reflection, which is good. It looks like it goes right 1, okay? It doesn't go up or down at all, honestly. So I think that is the only thing that we have here. I also want you to notice, let's look at our parent graph over here. This one starts as right 1, up 1. Okay, so let's go to where it starts. Right 1, up 1. Okay, good. This goes 1, 2, 3, 4, up 2. 1, 2, 3, 4, up 2. Okay, so it doesn't look like it's stretched at all either. So this one only has 1. It's going to be right 1. So when it goes, we're going to come down. This is f of x, and I'm going to label this as g of x over here. So this is our original function. It's going to be our f of x. Okay, so we only have right 1. So then we know that this is going to be plus 1 because we're going to the right 1. We are physically going to the right 1. And there is no transformations up and down. Okay, so I'm going to take my x value and add 1. So it's going to be 1. Take my x value and add 1. That's going to be 2. And then we're going to have 5. And as you see, that matches our graph exactly. And then nothing happens to y. Okay, so that's how we'd find my table. And this is my transformation table right here. Okay. So that is all we're going to have. Now, I want you to keep in mind, if there were to be a flip like this, you need to flip everything first with your transformation table. Please do the transformation of the flip first. Always do the flip first. I don't know how many times I can say that. Flip first, okay? And let's go ahead and let's do our domain and our range for this one as well. So we're going to have our domain, which is our x values, okay? And we come over across, bam, doesn't hit anything, hits 1, and it is included. So we're going to have 1, and that value for all our x's goes to infinity. Okay, let's do our range, which is our y values. So I'm going to start here, doesn't hit anything, doesn't hit anything. The first one it hits is going to be at 0, and it's included. And again, that's going to go to infinity. And this is the rate, this is for g of x, okay? So just a little bit on writing an equation from a graph, knowing how to make a graph, and then writing your domain and your range. Okay. Here's some of my favorite parts. Personally, for me, it's kind of like a game, which I really like. Yeah. So we have to extract roots from a radical. Look at the root / the index and get all these terms to have this exponent as best as possible, okay? This is what I want you to remind you of. This is called the index or the root, okay? So let's go this first one. This has a 3. That means I want to get everything in groups of 3. Groups of 3. This is what I want right here. Okay. So I'm going to zoom in a little bit. And for this first one, I noticed, I'm going to go to my calculator real quick, and I'm going to try, I'm going to try to do the cube root of 81. No, it doesn't work. If it helps you, let's go ahead and let's write some of our perfect cubes. Okay. So let's do perfect cubes. Okay. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And then the next one that we want to do is we want to do 5 times 5 times 5. And if we go ahead, that we already know that if we do 5 times 5 times 5, it's going to be way too big. But let's just go ahead and figure out what that is so we have it. And that's going to be our 125. Okay. So we see that 81 does not fit into any of those, but there is a perfect cube in there. I know that when I'm looking at 81, I know that I can do 27 times 3. And look, 27's in my group. Okay, that is what I want right there. Okay, so then I'm going to do the next one. Okay, so my x over here, I'm going to do an x to the third times x. The reason I did that is because 3 plus 1, there's a 1 here, correct, right? 3 plus 1 is going to give me 4, but I need them to be an exponent of 3 as best as I can. The next one I'm going to do is y to the third. That is already cubed. I'm good. Bingo. And then I'm going to go over here. I'm going to do z, and I want them to be in groups of 3. So z to the third times z to the third. I'm good, okay, because these add up to 6. A good rule of thumb is if this exponent right here, and in this case it's not going to be 4, but if these exponents right here are a multiple of the index, it's going to work, okay? So let's come over here, and let's move some things around, okay? So now I'm going to come over here, and this is going to be equals. I'm going to go step by step, okay? So let's start. What is the cube root of 27? 3, okay? Now I need to find the cube root of 3. I do not know what that is, so I'm going to keep that over here, okay? Because I can't do anything with it. Cube root of x cubed, those cancel, okay? So I can just have an x here. Again, these cancel, so I can just have a y. And what's happening right here is we're taking the cube root of y cubed. So those cancel. That's why we're doing that, okay? And then lastly, this cancels and this cancels. There's 2 of them. So I'm going to have z squared, okay? There's one other thing that we cannot take out that keeps underneath the radical, okay? So in the end, this is going to be my final answer, okay? I'm going to come down here and do this one again. Please notice that 32 is not on our perfect cube list. Because again, our index is 3, so we want to get groups of 3. Okay? So let's come over here. I'm going to do the cube root. And I know for 32, this can be the cube root of 8 times the cube root of 4. Okay? Because 8 times 4 is 32. So I'm going to go ahead and put 8 times 4 down here. Okay, let's start. Let's do x to the third, because again, we want them in groups of 3, times x to the third. We're good, because 3 plus 3 equals 6, which is what we're trying to get to. Okay? Y is a multiple, 12 is a multiple of 3. So this is going to work perfectly, okay? So I can come over here and I can do times y to the third, times y to the third, times y to the third, times y to the third. The reason I did that is because 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. That's where I want to get. Okay. Now, lastly, 7 right here. 7 is not a multiple of 3. So I'm going to have to do z to the third times z to the third. Now I'm at 6. There's 1 z left over because I need to get to 7. Okay. So let's go step by step. Cube root of 8. We already know is 2. Okay. We can't take the cube root of 4, so I'm going to leave that over here. Okay. I can take the cube root of all of these. 1, 2. I have 2 x's left over, so this is going to be x squared. And I'm getting that from here, 2 x's. Now I'm going to go over to the y. 1, 2, 3, 4. So I have 4 y's here, so I can do y to the 4th, because 1, 2, 3, 4. Same with the z's. I can cancel 2 of them. So I have z squared. This z right here, I cannot do anything with, okay? I can't cancel anything, so I need to put it underneath the radical. So this, my friends, would be your final answer, okay? The biggest thing I'm going to tell you is I want you to look at your index right here, also known as your root, and those are the groups you need to get it into, okay? If you have like an index of 2 or a square root, then you're going to have to get everything in groups of 2, okay? This right here tripped up a lot of people, so I'm going to work through this one. Put everything in fraction exponents if possible. Please know your exponent rules and properties. There are many different ways you can do that. Some are a lot easier than others. So if you want to decide that you want to apply the 1/2 exponent and multiply everything out first, by all means do that. That is not easier for me. Okay, I like to go ahead and go through, and I like to divide everything out first. Or I want to do my quotient exponent rules. Okay, so I'm going to come through. I'm going to leave my 36. I'm going to leave my 25 alone. Okay, I'm working with my x's now. They have the same denominator of 3, which means I can just subtract them. So 8 minus 4, I'm doing this right here. 8 minus 4 is going to be 4/3. Okay? The 4/3 is going to be on the top because it's bigger. So this is going to be x to the 4/3. Okay? Now I'm going to be working with my y right here. Okay? I cannot subtract them unless they have the same denominator. This is technically a 1. Now I need to convert it so they have a least common denominator of 3. So I'm going to put 3/3. Now I can subtract them. 3/3 minus 1/3 is going to be 2/3, and this number is bigger. So I'm going to keep that one on top. So this is going to be y, and this is going to be 2/3. Okay? And again, nothing is left on the bottom because they all canceled out. Okay? When we subtract. And then I still have this 1/2. Please don't forget it. Okay? Now let's go ahead and let's apply our exponent rules. So I can do this one first. 36 to the 1/2. Okay, I want you to keep in mind 36 to the 1/2 is the same as the square root of 36, which we know is just 6. And I'm going to do the same thing down here. I'm going to do 25 to the 1/2. That's the same thing as the square root of 25, which we know is 5. Perfect. Okay. Now with my exponent rules, I need to apply the 1/2 to both. So this is going to be x 4/3. 4/3 times 1/2. And then it's going to be y 2/3 times 1/2. And we can just multiply across, right? So we're going to have our 6. And then we're going to have our, this is going to be x to the 4/6, which we need to simplify. Do not leave it as 4/6. This is going to be 2/3. Okay? Then we're going to have y, and this right here becomes 2/6. Okay? 2/6. Again, please do not leave it like that. That is not simplified. That is going to be 1/3. And then we just leave the 5. Okay? Leave it like that. If it asks for radical form, then go ahead and do that, but you don't need to. Just leave it like that. If you're curious, radical form will just be 6x, or let me do this. Bring the x over here, okay? Remember, it's going to be power over root. So this would be power, root, and this would be, so we have our power and our root, and then we had 5, okay? This right here is radical form. This right here is exponential. I'm just going to put expo. I'm letting you know this answer is okay. Please leave it. Perfectly fine. Do not waste your time. That is the same thing. I want you to leave that. Okay. Now, I'm just going to have some of these examples here. Is maybe if you want to walk through them. Just knowing how to rewrite them. So this one right here. Okay, so we have our 4a to the 5th all over b to the 6th. And this is going to be to the 1/2. Okay, so if that's another way to write it. And if you want to check yourself, I know the square root of 4 is 2. And then I'm just going to multiply my exponents over here. So this is going to be a 5/2. And then I can just multiply my exponents here. And 1/2 of 6 is going to be b to the 3rd. Okay. That is going to be your answer. We cannot do anything else because we can't subtract them because they don't have the same terms. Okay. And then this last one here that I'm going to do is this is going to become, okay, so my index is 2. I need groups of 2. okay? Now, the other thing, too, is now we need to get a square root. So we have our 2, 4, 6, 8, 10, 12. I'm just kidding. I'm glad you probably questioned me on the other side of this video. 2. Okay, so now we need to get groups of 2. So we have a perfect square. So 1, 4, 9, 16, 25, and so forth, okay? I notice that my 18 right here can be written as 9 times 2. The reason I do that is because I need a perfect square in here, and that's where that comes from, okay? Now, with my m, since it's a square root, I just need everything to be in multiples of 10, okay? So here's another way that we could do it. I'm going to do m to the 10 times n. The reason I did that is I need them to equal 11, okay? The next one I can do is n to the 12th is already even, so I can leave it. And then k, the closest I could get is 12, and then times another k. Again, I want them to get in groups of 2, or multiples of 2. So I come down here and I know that the square root of 9 is going to be 3. Okay? I cannot take the square root of 2, so I need to leave that underneath the radical. Okay? Now with my exponent rule, since this is even, remember, with this, it's going to be my power over my root. This is going to be m, my power over my root. This is just m to the 5th, so you can just divide. So this would be m to the 5th. And again, we can't do anything here, so we need to put that underneath the radical. Now looking at this one, this is going to be the same as n. Remember, my power over my root. My root is 2. This is just the same thing as n to the 6th. So n to the 6th. Might need to move this over a little bit, okay? Same thing, this one right here, last one. We can do the same thing, k, 12 divided by 2, because that's my index, and that's just going to be k to the 6th. And we can't do anything with that k, so I'm going to leave it, okay? This would be your final answer right here, okay? And that is in radical form, okay? I'm going to briefly talk about the composition of functions, and then that is the last thing I'm going to do for you guys today. So with this composition of functions, the way you need to check is you need to check f of g of x, or I'm sorry, in this case it's going to be h, and then h of f of x. Okay, if they both equal x, that means they are inverses, okay? This has to happen to be inverses, but we don't know that yet, okay? So we got to check. So what I'm going to do is I'm going to take my f of x, okay? So this is f, and then we're going to have h of x. So I'm going to go ahead and I'm going to plug my f in. So this is 3. Whenever there's an x, just put parentheses because we need to plug it in. And my h of x is going to go in this little space right here. So 1/3 x minus 6. Okay, I'm plugging this h of x in right here. If we just simplify here, we're going to have x, and this is going to be minus 22. I can already tell right here that it is not going to be an inverse because it does not equal x. So you can stop right there, okay? Now, I'm going to go ahead and I'm going to change this over here. I'm going to show you one that does work out. Okay, so let's erase all this right here, okay? So let's say over here that I ended up having like x minus 6 divided by 3. Okay, so let's try this one. X minus 6 divided by 3. Okay, this is nice. Look, I already know that these two cancel, so if you really want to see it, it's going to be x minus 6 plus 6. This is just x. This one works. Okay, now I'm going to come over here and I'm going to do h of f of x. So I'm going to have my h. Whenever there's an x, just put parentheses, minus 6 divided by 3. And now I'm going to plug in my f of x right here. 3x plus 6. I can see right off the bat these are going to cancel. And I'm going to get 3x over 3, which is just equal to x. Bam. since both of these work, okay, f of h of x and then my h of f of x work, I know that given the composition of functions, these two are inverses. Okay. This means f of x and h of x are inverses. Okay. Again, that was a lot of information, but this one is probably going to be difficult along with this one. Please know your exponent rule.